All right, let's get started. Ironically, this first unit in this chemistry class doesn't have much chemistry in it. It's going to seem like it's almost completely math, but there's a reason. So it's all about numbers, 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 and that's because chemistry is an observational science. Scientists really like to quantify things, so numbers and math are inevitable, and we need to spend a little bit of time making sure that we're all doing it right. Now, observations. So what we observe we call quantities. And any observed quantity, any observation, is going to properly have two parts, a magnitude and a unit that goes with it. Technically, it's got three parts. The third part is an uncertainty, but we're not going to talk about that much in this class. All right, so what are these quantities that we are measuring or describing? Um, so a quantity is sort of the philosophical, ethereal thing that we are measuring. And a lot of these you're probably already familiar with, like let's say length and time. So those are two examples of quantities. Now you are probably familiar with several different ways to quantify or to describe length. You could talk about inches, you can talk about miles, you could talk about microns, or even light years. Now, those are all different units that describe the quantity of length, and they provide some sort of scale perspective, and some units are more convenient to use for some ranges of lengths than others. So you wouldn't, for example, talk about, the size of a tabletop in terms of meters or in terms of miles, I'm sorry, because most tabletops aren't miles long. And it turns out that these quantities here, length, mass, time, electrical current, temperature, amount, and luminous intensity, are all that is needed to describe anything or any quantity in our universe. Believe it or not, just those 7. More on that in a bit. Because you're probably thinking there are more than 7 things to describe in the universe, and this is true. Now let's get to the units. There are many units that describe length. I talked about a couple. There are many units that describe time. And for a very long time, units were all over the place. They were originally based on, in some cases, the body part of a local ruler. I mean, this is where the term foot for length is, because at one point in time, it was related to the length of someone's foot. The unit of length of a yard was related to someone's arm length. It was often talked about the difference between the tip of your index finger and the tip of your nose. Now, obviously, if there's a change in administration, unless your people are always exactly the same size, this is going to be a problem. So a while ago, back in the 1800s, some folks, mostly in Europe, actually mostly in France, sat down and said, okay, we need to standardize, these units so that we all know what we're talking about. This made scientific collaboration easy. It even made things like trade easy. And so this is what resulted was called the Système International d'Units, or the SI system. So that just means International System in French. And originally, let's say the kilogram here was the base unit of mass. So in France, in a very secure vault, there is a block of a very rare platinum iridium alloy, and the mass of that block is the kilogram. And people would come there, and they would compare a mass of their standard block to that one, and so then they knew what a kilogram was, and they could bring it home. And then so there's an official United States kilogram that is based on a match to the French one. In that same vault, very close to it, there is a rod of that same platinum iridium alloy. It's got 2 scratches in it, and originally the distance between those 2 scratches was the meter, and so on and so forth. So again, be cognizant of the difference between the quantity and the unit that is used to describe it, and that there can be more than one unit that can describe a particular quantity. And what else do I want to talk about this slide? Oh, symbols. So you're going to need to know these. And the idea is that it gets kind of old to keep writing kilogram or to keep writing meter, so we tend to abbreviate them. So meter is just M, kilogram is kg, second is S. The other ones, temperature, are kelvins, and the other ones, mole, MOL, we'll get to as we need to. Right. So that is units and quantities. Now, these are the base units in the SI system. Now, I said that collection of 7 units can be used to describe anything in our universe. And that's because they can be combined. And so this is something that is called a derived unit. And let me scribble it on here. And as the name would imply, those are simply quantities that must be described with a combination of 2 or more base units. And let me give you some examples. First one is speed, properly called velocity. Now, the definition of velocity is the distance something covered divided by the time that it took to cover that distance. So distance would have units of length, and time would have SI units of seconds. So therefore, the SI unit of velocity, which is a derived unit, is simply a meter per second. And when you are converting between English and math, the word per often means divided by. Another example is volume. Now, volume is a derived quantity, so think back to a geometry class at some point somewhere. And that, how do you get the volume of, for example, a cube? And you were just told to multiply length times width times height. And that's your hint. So it's going to have, the volume is the product of 3 lengths. So it's going to have units of length times length times length, or length cubed, or meters cubed. So the cubic meter is the SI unit of volume. And so the reason why those 7 units can describe anything is because they can be combined in a nearly infinite number of combinations to give you derived units. All right.